Hello viewers, I'm Kausalya. Today we are going to discuss about the topic resistors in series. So first let us have an introduction about resistor. So what is a resistor? This is the symbol of a resistor. It is denoted by the letter R and the resistor has two terminals. Okay, that is it has two ends. This is one end and this is another end. And here this is a passive element. Okay, elements are broadly classified into active and passive. Active are nothing but they are the sources, and passive are nothing but they are the elements which themselves do not produce any output, they just accept the input, right? So a resistor is a passive two terminal electrical component that provides electrical resistance. So, as I said, it is a passive device, right? And it has two terminals. And what is the purpose of having resistor? It provides electrical resistance. So, what is mean by resistance? Resistance is a property of opposing the current, right? It doesn't allow the current to pass through it freely. So, the main purpose of resistor is to reduce the current flow, right? This is what just now I said. It opposes the flow of current, or in other words, it reduces the amount of current that flows through it. And to lower the voltage in any particular portion of the circuit, that is, in order to create a voltage drop, right? So, what is meant by voltage? As we all know, V is equal to I into R, right? So, the value of resistance is always fixed, right? For example, it may be some 5 ohm or 10 ohm. And depending upon the amount of current that flows through the resistance, it produces a voltage drop, right? So, in order to lower the voltage, or in other words, in order to create a voltage drop, we can use the resistors. And the SI unit of resistance is ohm, right? And this is the symbol of ohm. And the next thing is, we are going to discuss about resistors in series. Resistors in series. So here, if the resistors are connected end to end, then the combination is said to be in series. That is, I'll explain you with the circuit diagram here. So look at this circuit diagram, right? So here, end to end connection. What is mean by end to end connection? That is, you see, consider this resistor R1. Its two terminals are, this is one terminal and this is your another terminal, right? Similarly for R2, this is one terminal and this is your second terminal. For R3, this is your first terminal and this forms your second terminal, right? To simply we can say, that is, the ending point of one resistor becomes the starting point of another resistors. Can you get? Here you see, this point is the ending terminal of R1, whereas this point is the starting terminal of R2. So, when ending point of one element becomes the starting point of other element, then the two elements are said to be in series, right? So, here in this case, R1, R2, R3, these three resistors are connected in series, right? Because the ending point of one becomes the starting point of other. The ending point of R2 becomes the starting point of R3. So, all these three resistors are said to be in series. So, the terminal A and B are connected to the voltage source, right? So, across the terminals A and B, we are having a voltage source V. The same diagram you see, this can be drawn like this, right? Again, you see, the ending point of resistor R1 becomes the starting point of resistor R2. And similarly, the ending point of resistor R2 becomes the starting point of resistor R3, right? So here, since we are having three resistors, right, in series, we are going to replace the three resistor by its equivalent resistance. So, this is what which is shown here, right? We are having a voltage source and we are having two terminals A and B, and instead of drawing three resistors, we are replacing the three resistors by a single resistor. That is, RT is nothing but total resistance, right? So here, the current flowing through the three resistors remains the same, right? Can you observe it? Because since the elements are connected in series, the same current I flows through all the three resistors. Similarly, again here, this is also a series connection, right? So again here the current flowing through all the three resistors are same. So the current flowing through all the resistors are same, right? So this combination is known as series combination. And there will be a voltage drop across each resistors, right? Because whenever a current flows through a resistor, it produces a voltage drop. So to find the equivalent resistance, now we are going to calculate the total resistance. So as we know, V is the applied voltage and I is the current. And V1, V2, V3 are the respective voltage drop across R1, R2 and R3. Right. By Ohm's law, V is nothing but I into R. Right. So V1 can be written as IR1 and V2 as IR2 and V3 as IR3. Right. Since this is a series connection, the current remains the same. So what about the total voltage? The total voltage V is equal to V1 plus V2 plus V3. Right. Now substitute the values of V1, V2 and V3 here. So here in these terms, I can be taken commonly outside. So when you take I outside, then this becomes R1 plus R2 plus R3. So here we can be written as I into RT. Right, where RT is nothing but, that is the total resistance is nothing but R1 plus R2 plus R3. That is the summation of all the three resistors. Right. So here the sum points to be noted are, so in series combination, the current is same through all the elements, right? The current flowing through all the three resistors are same. For example, if 5 amps flows through resistor R1, the same 5 amps flows through resistor R2 as well as R3, right? And here, the equivalent resistance RT is greater than greatest individual resistance of that combination. That is, for example, let the equivalent resistance be equal to some 10 ohm here. Right, that is equivalent resistance is nothing but R1 plus R2 plus R3. So here this can be, that is, it is a combination of resistance, right? Let the value of resistance R1 be 1 ohm and let this be 3 ohm and let this be some 6 ohm here, right? So this equivalent resistance is greater than the greatest individual resistance of that combination. So among 1, 3, 6, which one is greater? 6 is greater, right? So this 10 ohm is greater than 6 ohm, right? That is the logic, that is the meaning here. Then the next thing is applied voltage is equal to sum of voltage drops. That is applied voltage V, okay? V is equal to V1 plus V2 plus V3. For example, let the supply voltage be some 100 volt, right? So let the voltage drop across V1 be some 20 and V2 be 30 and V3 be some 50. Right, again 50 plus 30 plus 20 gives you 100. And finally, the total resistance. So total resistance is nothing but sum of individual resistances. This is the thing we already know. Right. Now we are going to discuss about voltage division in series circuits. So voltage, supply voltage is equal to voltage drop across the resistances. So V1 plus V2 plus V3. So by Ohm's law, V is nothing but I into RT, right? So RT is nothing but the total resistances. So I is equal to V by RT and here RT is nothing but summation of the resistors. So R1 plus R2 plus R3. Now we are going to frame formulas for V1, V2 and V3. So when you consider V1 here, so V1 is equal to I into R1. What is the formula for I? Formula for I is V by R1 plus R2 plus R3, which gets multiplied by R1. Similarly for V2, which is I into R2. So I, we know the formula here. So just it gets multiplied by R2. And similarly for V3, it is given by I into R3, and the formula for I is given by V by R1 plus R2 plus R3 multiplied by R3. Right. So this is the basic introduction about resistors in series. If you have any doubt, let me know in the comment section. Thank you.